divided by 2 C equivalent. Whatever is the C equivalent that you have. Net equivalent. No, you C equivalent is what? Whatever capacitance are there connected in series, you are taking out an equivalent. All right. So this is your net energy of the whole system that you have. Now, if we connect these in parallel, this was whole theory about series combination which we had studied. So many of you have answered it correctly also. Okay, now if we talk about the parallel combination. So see, in this chapter, what is left? Parallel combination that we'll do right now, and some different capacitors also we'll see. If we have different combination of capacitors, because see, you won't be given only a series, you won't be given only parallel, you will be getting combinations of series and parallel. So you should know how to solve it. If you have different connections, you should be able to identify series and parallel out of the whole circuit only. So that's why let us do it separately for parallel, and then we'll see it how to see it for the combination. So for parallel combination, so the way Maimuna had answered us and told us that charge remains the same in case of series combination. Remember, potential remains constant for parallel combination. So parallel combination means what? If I say this is a wire, here a capacitor has been added, then another capacitor has been added in this wire, then a third capacitor has been added in this wire in this manner, and this whole is connected to a battery of potential V. Then charges will flow. The charges will get divided because branching has occurred. Let's say this is C1, this is C2, this is C3. But V will remain the same. Potential remains the same. Reason, see, V is there in the same wire till here, V is there in the same wire till here. Potential, just remember, potential remains the same whenever you have parallel combination. So if you're able to identify that potential is getting same and you're not able to get it, whether it is series combination, whether it is parallel combination. So if you say see voltage is same, it definitely means it's a parallel combination. So in parallel combination, voltage across each capacitor, this remains the same. Each capacitor remains the same. So here what gets divided? The charge. This gets divided. Now how does it divide? That is directly dependent on the capacitance. Whatever capacitance that you have, it is dependent on it. Now the formula of it. See, in this case, what is remaining the same? The charge is remaining the same. So what will be the net charge of the system? Net charge of the system, Q, that is being released, it will be the addition of all the charges. Means if I have Q1, Q2 up till Qn I have. This charge only got divided among all of them. No. So if this charge only got divided, this definitely means what? If I add all of them together, I'll get my charge back. Now Q is equal to what? Q is equal to CV. So net charge is what? Net capacitance means C equivalent multiplied by the net voltage of the system. This is equal to Q1 is equal to what? Q1 is equal to, this is equal to whatever is the capacitance of the first one multiplied by the potential. So Q1 is equal to C1 multiplied by potential of the first one. But see, potential of first one, potential of second one, all of them are equal. Plus, regarding charge of second one, C2 is the capacitance, potential is still V because this is combined in parallel combination and potential is same. Up till C and V, all the potentials V will get cancelled. You will get the C equivalent as C1 plus C2 up till plus Cn, means whatever number of capacitance that you have, keep on adding them directly. Just keep on adding them up capital plus CM. So this becomes your net formula of capacitance, equivalent capacitance if they are capacitors are combined in parallel combination. Had it been series combination, then 1 by C equivalent, just reciprocal all of each of them, put the reciprocal and add them. Now if you have to calculate the charge for it, so charge will be what? Let's say charge for the first capacitor, this will be C1 multiplied by V. Charge for the second one, this will be C2 multiplied by V. Charge for the nth one, Cn multiplied by V. Cn means what? For example, if I say fifth, Q5, so it will be C5 multiplied by V. V won't get changed because these are combined in parallel combination. So this will be the formula of the charges that you have. All right. So note it down. Then I'll give you a question. We'll do a question on parallel combination as well. And then we'll see how combinations of parallel and series are utilized. So from here start doing, and I'll do a question. At least first to 3 parts you should be able to do it formula based. So at least first 3 parts. C equivalent, I think in C equivalent you don't even need calculations. Then the total voltage also is written in front of you. And then the total charge. Just multiply the first and second part, that will give you the total charge. Quickly, all of you, all the students should submit their answer, at least first 3 parts. Then I'll discuss it. Yes, Khalid. First part is correct. Quickly answer the second and third part as well. Others also respond. Yes, Samira. First is correct. Khalid, second part is also correct. Try the charge across each. Good, Salman. Both the parts are correct. See, Salman, I think you know it. It's just typing it in. Faraday is always written with capital F. All
Yeah,
right.
yes,
Yes,
ma'am.
yes. All right. Okay, yes, Samira. Sarah, both of them are connected in series or parallel? Both of them are connected in parallel. Parallel combinations formula is this. Coulomb, Khalid, Coulomb. Yes, yes, Sarah, now is correct. Now it's correct. So, who all have not answered yet? Samaira, Khalid, Salman, Sarah. They have answered. Memuna, what about you? Your answers are left, Memuna. All right, let's discuss it then. Memuna, how are they connected? Can you tell me the answer of the first part, Memuna? Yes, Salman. Third part is correct. Fourth part is also correct, Khalid. Okay, she's having network issues. That's why she was not able to answer. Let's discuss it now. Khalid, meanwhile, you can try the fifth and sixth part also. C equivalent is very easy. C equivalent is what? C1 plus C2. C1 plus C2. C1 is 5. This is charge across the first one. Fifth answer is charge in each. Okay, 50 coulombs and 100 coulombs, I believe. Khalid?
Yes, teacher. Yeah.
Yes, yes.
First one
Okay.
is 50 and that's correct.
Okay. All right. Hania, 15 coulomb, correct. 15 farad. It will be 15 farad. Farad is the answer. 5 plus 10. This gives you 15 farad. This is your C equivalent. All right. Total voltage. Total voltage, these are connected in parallel. And even if they had been connected in series, total voltage is this only, no? That is 10 volt. So total voltage, this is V, that is 10 volt. Yes, Salman, fourth part is right. Hania, second part is correct. It will be 10 volt. Now charge across each means what? Total charge, not charge across each. Total charge means total capacitance means C equivalent multiplied by total potential. C equivalent is 15, potential is 10. That gives you 150 coulomb. Now voltage across each. See, both of them are connected in parallel. We have seen parallel connections have the same voltage. Whatever is the voltage of the whole system, that is the voltage of your parallel combinations. So for fourth part also, V1 is equal to V2, which is equal to V. That is 10 volts only. Fifth part, see charge across each one of them. How do we calculate? Charge across the first one gives you capacitance across the first one multiplied by voltage. Means C1 is 5, voltage is 10. That gives you 50 coulomb. Similarly, you have Q2. Q2 is what? C2 multiplied by V. C2 is 15 multiplied by V is 10. This is 100. C2 is 10. C2 is 10, that gives you 100 coulomb. So you can see also the total charge that we were getting was 150 coulomb. And here also we are getting 100 plus 50 coulomb. That gives you 150 coulomb. Sixth part says energy, no? Energy in each. So energy's formula is the same. Sixth part says energy will be what? Use half CV square because potential is common, so you can use half CV square. So energy for the first one will be half C1V square, means half into 5 into 100. That gives you 500 by 2. It means 250, not coulombs, joules. 250 joules. Then U2 will be what? Half C2V square, means half. C2 is 10, V2 is 100, means 10 square is 100 only. This becomes 1000 by 2, that is 500 joules. Last part says what? Total energy. Total energy is what? Add both the energies, you will get the total energy of the system. This will be 250 plus 500, you get it as 750 joules. This is your final answers. Correct? Any doubts still here? Yes, 250, 500 and 7. Good, Khalid. So Khalid has answered all the parts. Most of you have answered this question. Most of you have done. So all those who have not written the solution, quickly write it down. Then we'll see if series and parallel both are utilized, how to solve the questions. Done, class? Let's see combination of series and parallel. Now we'll begin with questions only. The theory part, you know the theory part. The equivalent capacitance for series was just by taking the reciprocal of it and adding them, and then the equivalent capacitance of whenever you take it for the capacitance in case of parallel, then just add it, simply add it. So see, we'll begin with question only. One capacitor is connected in this manner. This is 10 microfarad. Two capacitors are connected in this manner. This is 5 microfarad, this is 10 microfarad, and all of them are connected to a cell which is 10 volts. So let us find out the equivalent capacitance. Calculate the C equivalent capacitance of the system. So see, in this question, if you see 5 microfarad and 10 microfarad, this C1, C2, C3. C1 and C2 are not connected in any ways, means they are though connected with the help of wire, but they are not connected in any specific arrangement like series or parallel. If I talk about C1 and C3, C1 and C3 are also not connected either in series nor in parallel. They have different charge, they have different voltage. But if I talk about C2 and C3, how are they connected? C2 and C3. How are C2 and C3 connected? Parallel. Samira, parallel. Correct. Both of them are connected in parallel. This question we have done just now. So what we can do, we can at least find out the answer of this, the equivalent capacitance of at least this much part. So the equivalent capacitance of C23, see, C23 in this, both these capacitors, C2 and C3, these are connected in parallel. So C23 will be what? C2 plus C3. That's how you calculate for parallel. C2 is 5, C3 is 15, C3 is 10, that gives you 15 microfarad. Now, this combination C23, let's draw the circuit again. This was what? 10 microfarad, C1. Now, instead of the whole setup of that parallel combination, we have just one capacitor whose name is C23, means this 15 microfarad. Now we don't have those two wires. Now we have this. Both of them are connected to a cell that is 10 volt. Hania, are they connected in series or parallel? C1 and C23?
Series.
Series. They are connected in series. Now in series, how do we take the net capacitance? We take out the C equivalent as C1 plus the other one as C2, 3. So 1 by C equivalent will be what? C1 is 1 by 10. This is plus 1 by 15. So 1 by C equivalent, this becomes what? This is 150 is the LCM. So this will be 10. 10 plus 15, this is 25. So this becomes 25. So C equivalent is what? C equivalent is simply 6 microfarad. So 6 microfarad is what? This is the complete equivalent capacitance of the whole circuit. C1 was 10, C23 is parallel combination of C2 and C3. Clear to all of you? Any doubts? Okay, so just note it down, then we'll see different circuits. This is one of them. After this other circuit I'll give you. You try to find out the equivalent capacitance of it. See, in case when we'll be studying current electricity, no, resistors will be there instead of capacitor, and whatever formula you have studied for parallel and series, that will get swapped. So just try to understand in this capacitor easily, so that it becomes easier for you to understand when we'll be doing current electricity. And in your next class, I'll be discussing your test papers as well. On Wednesday, we'll discuss the test paper that you have. So most of you have done it correctly only. See, all the capacitance value is C. Take it as capital C only. C, C, C. So answer me in terms of C only. So you have to find out, calculate the equivalent capacitance between A and B. So this looks long, but see, this is very easy. Both of them are connected in a way. Then the resultant with this will be connected in a way. Then that will be connected with this capacitor in a way, and all the three will be connected in a way. So that way you have to identify whether both of them are series or in parallel. If they both are in series, or if they are in parallel, then the resultant will be in series or parallel with this. Calculation is very easy because you just have C with you. Just try it once. Anybody that who gets the answer, just send me quickly. This is not a very tough one. You'll get the answer in terms of C only. See, for the ease of calculation, let's just name the capacitor. Naming them won't be different because all of them are identical, having the capacitance C. But let's name it. Let's name it as 1. This is second. This is the third one. Fourth, fifth, and this is the sixth one. Okay, so Salman, how are 1 and 2 connected?
Parallel.
Parallel. Perfect. So 1 and 2 are connected in parallel. See, main thing you have to identify this. Otherwise, your questions are easier. You know the basic mathematics, no? Adding them, taking the reciprocal, adding them, taking the LCM. Main thing is identification of series and parallel. So both of them are connected in, it means both of them are connected in parallel. I can replace it with a single capacitor, that is C12. So C12 will be what? C plus C, that gives 2C. Now how my circuit looks. Now this is given, this is given. This manner, we have another capacitor. This was point A. This was point B, C, 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 C. This is the fifth, sixth, fourth, third, and C12 has been combined. C12. This C12 only. I have reduced it to a single capacitor C12. Samaira, can you tell me how C12 and 3 are connected? Series. C12 and the third capacitor, both of these are connected in series. See, single wire is used. They are connected in series. So series, how do we calculate the equivalent? So C123. I'm just naming 1, 2, 3, 1, 2, 3 in the manner so it becomes easier for us to remember which all capacitors were combined. So this is basically C12 plus 1 by C3. So C123 is what? C12 is 1 by 2C and this is plus 1 by C. So 1 by C123, this will be equal to, total LCM will be 2C, 1 plus, here it will get multiplied by 2. So C123 will be equal to 2C divided by 3. So this has been reduced to 2C by 3. Now see how the circuit now looks like.
And by the way, how C12 and C3 are in series?
See, these are connected by a single wire. No, the same wire is there. So it means even if I take it like this, if I put it like this, now they look in series. It's just that a bending has occurred over here.
Okay.
All right. See, the charge that will flow across this, that will be the same. If you are, even if you are getting confused, see the charge that will flow across it will be the same. If I talk about the potential will get divided because of the capacitors. So it means that they are connected in. Salman's capacitance will come, Salman. C will not get eliminated because you don't have the value of C. So check it once again. C will be there. Khalid, is it clear? Capacitance connected in series?
Yes, teacher.
All right. Look by charges or voltage if you get confused. This is very easy one. Otherwise, the circuits also we'll discuss where you have to check it by charge and voltage only. So here you can look at by charge also. Charge will be the same across this wire. See, charge will get divided over here, but charge will be the same here, but potential won't be the same over here. Now see how the circuit looks like. These three are there connected. The fifth one, the fourth one, and the sixth one. Now one more has been connected to it, not one more, the previous one only that was written. Correct. Perfect, Salman. So Salman has answered this question well. Correct, Salman. Good. This is the answer. So this will be C123. Whole C123 has been connected here. Why? Because we have seen this was C1, C12 was there. We combined it and formed it a single capacitor. Then with C3, it was coming out to be in series. We combined it and made it a single capacitor. Now this single capacitor. So Khalid, how are C1, 2, 3 and 4 connected?
In parallel.
Parallel. See, because branching has occurred, so definitely charge will get divided, and it means branching doesn't affect your voltage, so they are connected in parallel. So they are connected in parallel. So it means C1, 2, 3, 4. This will be what? C1, 2, 3 plus C4. C1, 2, 3, we have calculated it was coming out to be 2C by 3 plus C4 is C. So this will be what? 3 plus 2, 5C divided by 3. This is C1, 2, 3, 4 means net capacitance of this. Now let me draw again the reduced form of C1, 2, 3, 4. This is 5. This is now C1, 2, 3, 4 and this is 5, 6. This is C1, 2, 3, 4. This is 5C by 3 and this is A and B point. Sarah, tell me how are all the three connected? Series. All the three are connected in series. So C5, C6 and C1, 2, 3, 4, these are connected in series. It means 1 by C equivalent of the whole circuit. This will be what? 1 by C5 plus 1 by C6 plus 1 by C1, 2, 3, 4. All these three, these are connected in series. So 1 by C equivalent will be what? 1 by C plus 1 by C plus, this was what? 5C by 3. So reciprocal will be 3 by 5C. Okay, Salman, come. So this will become 2 by C, or I can directly take the LCM as 5C only. If I take the LCM as 5C, I have to multiply this by 5 plus, multiply this by 5 plus 3. 5 plus 5 is 10, 10 plus 3 is 13. So C equivalent is 5C by 13. Correct, Khalid. So C equivalent will be 5C divided by 13, this much farad. Clear to the rest of the people except for Khalid and Salman? Sarah, Samaira, Hania, Memuna, clear?
Yes, ma'am. Yes, ma'am.
All right. So write down this also. Just quickly write it down. Yes, done?
Yes, ma'am.
All right. Now, I think you will be able to manage if capacitors keep on adding over here. A different method let's study in which your questions do come. If you have potential divider method, that is also used a lot, or short circuit. So understand how to identify it. How to identify, first I'll tell you how to identify a short circuit if you have a short circuit with you. See, short circuit basically means what? This, whenever you say in your daily language and common language also, you must have used the word short circuit. Circuit has been shorted. So what happens in this? For example, this a bulb has been connected. Bulb is there in your circuit. If I add another wire over here, what will happen? Whatever current or whatever charge that will flow across this, instead of moving across this bulb, no, all of the current or the charge flows through this wire and goes back into the cell. This is the path or the route of it. If I cross a wire in this form, no wire or no current or no charge flows through this. So tell me one thing, if no charge or no current flows through the bulb, will the bulb glow? Will it glow?
No.
No, it won't glow. Because no current has been there, no charge has been flow. So how can we say the bulb will glow? It means instead of drawing this whole circuit, I can write this circuit as this also. This has the same meaning, no? Charge is flowing. Charge or current, these are flowing and coming back into the cell. So wherever you get a short circuit you get in the case if you have, let's say, a capacitor. Capacitor has been connected with a wire all along. Now, after connecting it to the wire all along, see what will happen. Instead of the charges moving through the capacitor and making the working of capacitor occur, all the charges will flow through it. So the capacitor is of no use to me right now. Instead of drawing this circuit, I can write it in this manner also. Why? Because there is no work of capacitor. This circuit 1, this is equal to this circuit 2. In function, both of these circuits are equivalent to each other. In function, neither this one is glowing, neither the second one is glowing. In case of capacitor, neither the first one is working, nor the second one is working. It means what? I can reduce it in the form of a single wire. So if you get such a case where any circuit has been shorted, a capacitor is there and a wire has been added in this form, provided no other wire is coming out here, otherwise what will happen? That other wire will provide the charge and the circuit will flow. Not in this manner. Another wire has been, only this part. Then you say circuit has been shorted, short circuit is there, and you can replace it with a single wire. So if you have a very complex circuit, just replace it with a single wire and your work gets easier. If the circuit gets shorted, then you have to remove the capacitor or whatever device you have. In case of resistor also, we'll see the same. Resistor is there. Add a wire. Your circuit becomes short. So you can write it as a single wire only. All right. So this is utilized most of the times with potential divider method. See, potential divider method, what happens? Potential divider method. See, in potential divider method, what happens? If let me explain you with the help of example only. 1, 2, 3 capacitors are there. All right. C are the capacitance. Wire has been connected in this manner, but had this been the case, then both of these capacitors would have get shorted and I would have replaced it with a single wire. But this is also there. Now what will happen? This will provide charge to them. Or for this capacitor, this would have been shorted, but this wire would have provided charge to them. So this is not a case of short circuit, remember. Short circuit, it would have been short circuit if only this wire would have existed, or only this wire would have existed. Now see how to check for potential divider method. This point is A, this point is B. VA is here. Branching does not affect your potential, your voltage. Voltage doesn't get divided if you have branching. It means VA is the potential here. VA will be the potential here. In this wire also you have the potential as VA. Move along with this wire. It means here also your potential is what? Your potential is VA. So this side will receive VA, this side will receive VA. How? This wire's branching is not getting affected and this wire's branching is not getting affected. You're getting VA all over here. Now regarding VB, if VB is the potential of B point, this will be having VB, move along with it. Same wire. This will be VB, same wire. This will be VB. First tell me, is it clear how to write VA and VB?
Ma'am, can you explain again?
I'll explain again. See, this was your circuit given to you. Now, this is A point, it has potential VA. This is B point, it has potential VB. Keep on moving along with the wire. Just trace it. And wherever the potential is there, wire is there, capacitor is not coming. Till that time, till that point, potential will be the same. For example, this is VA. So I'm moving. A capacitor has come. It means till here only it will be VA. Branching was there. Let's move along with the branch. Till here. This will be the same because now capacitor has come. Other side would have been will get different potential. Move along the different side. This will be VA. The rest of it we cannot get it. Why? Because apart from this, only this and this, these are only having potential VA. About this, move along with VB. Here you are getting what? See, move along with this. Till here you are getting VB. Move along with this wire. Till here you are also getting VB, and till this point also you are getting VB. It means this wire is VB. So whatever potential are there in this wire, that write it as VB. And whatever potential are there in this wire, write it as VA. Now, whatever potential you are getting, V between, just write the points VA and VB. All right. Write the points VA. Let's say this is VA and this point is VB. Connect them. So first between VA and VB, we are getting this capacitor. Write it as C. Now again, between VA and VB, we are getting this capacitor. So we had taken 2 points, VA and VB. Connect this capacitor also. Why? Because this is coming between A and B. Then this is also coming between A and B. Just connect it. Now, if you arrange it properly, if I write the wire straight, this is basically this case. 3 capacitors are connected in parallel. So C are there. It means net C equivalent capacitance will be 3 times C. I'm repeating again. Then I'll give you a question also. We'll do a question in this manner, in this based only for potential divider method. So as to you understand how to apply potential divider method and when to use short circuit. See, this was the circuit given. Potential A till wherever the wire was there and capacitor was not coming, we had added it as VA. Then till the point wherever potential was there B, we had written it down as B. Now, how many potentials you are having? VA and VB. Mark those 2 points. Had there been a third potential, I'll give you a question based on third potential if required. Write it that point. All the points that are there in your system, write them down. And whatever potentials you are getting, no, just keep on connecting them. Like VM and VB was there. We had the first capacitor connected. V and VB connected. V and VB connected. Had there been a third point C, then you would have seen that A and C were connected. So A and C would have been connected. B and C would have been connected if C would have been there. Right now, forget C. You have this circuit with you. A and B have been identified. A and B have been connected. If you look at carefully this is 3 capacitors which are connected in parallel. So how do you get the net capacitance? C plus C plus C, that gives you 3C. Is this clear now? We'll do a question also. Let us do first a question. Then you can copy everything down. Because without the help of the question, this won't get clear. Third question. See, all of them will be having the same capacitance. See, so 5 capacitors I've connected. This is A point, this is B point. All of them are having the capacitance C. Now I have added a wire here and I have added a wire here. And I have also added a wire here. Here I have added a wire and this is left. This is your circuit right now. So this is 1, this is 2, this is 3, this is 4, this is 5. Can anybody see a short-circuited wire? Anyone? Yes, potential divider method. I'm again explaining you. Don't worry. In this question also. Yes, Salman.
Fourth one.
First one.
Fourth.
Fourth one. Correct. Perfect. Yes,
The fourth
Anya.
one.
Fourth one. See, this is short-circuited. So this means this is of no use. Let's redraw the circuit. It's just complicating our circuit. This is of no use. No current will be flowing it through, no charge will be passing through it. So it will act as a single wire. Now let's redraw it. 2 capacitors are there, third one is there, fifth one is there. Wire has been added in this manner, wire has been added in this manner, fourth has been gone. All of them are left now. This is point A, this is point B, all of them are having their capacitance as C. Now, okay. See, remember I'm explaining this potential divider method again because many times this do come in your examination. Point A is there. Start moving along with point A. Whichever capacitor you get, put it as VA. So let's move along with it. Till here we have reached. A capacitor is there. Can we jump and cross it? Khalid, can we jump and cross it and write the same voltage?
Yes.
Capacitor won't change our potential.
Oh yeah. No.
Capacitance changes your potential, so you cannot cross it because potential is getting changed. So till here this wire is having VA. Now this wire is also the part of this. Potential doesn't change because of branching. So move for this wire. This wire we have reached, it has been branched till here only. Now here also I'm getting a capacitor, here also I'm getting a capacitor, here also a capacitor was there. It means this was the total VA that is possible. So this side will be VA, this won't be VA. Reason? This is not a part of that voltage A. And then this side will also be VA, this side will also be VA. First tell me, is this clear? Especially Khalid, you tell me. Clear?
Yes, teacher.
All right. Now, regarding the second one. All right. Let's say this is not connected to B because see, this wire will be receiving VB. So this wire, this is receiving VB. This is VP. All right. Now, this part, this is connected by the same one. No. This has a third voltage. See, we cannot write VB over here. Why? Because capacitor has blocked it. Now, this wire will be having its own voltage. This. There will be same voltage in this wire flowing. Agreed? Yes or no? These are the three voltages possible. So let's name it as something else. Let's say this is some voltage VC. Write it as VC, 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 VC. All the points, all the voltages have been separated. First tell me, is this clear to all of you till now? Did it get clear?
Yes, ma'am.
Yes, ma'am.
Khalid?
Yes, teacher, clear.
Yeah. Now see how to write it further, because this is an easy step. This you will be able to do. You just have to trace the wires. No. Now how to write it, how to make it into a circuit. You have divided the potential, but how to write it? Now see, you have three voltages now. So write all of them. VA, VB, VC. You have three voltages now. Or VB and VC. Let me reverse it, because both VB is over here, no? Let me reverse it. So this is VB, this one will be VC. This one will be VC and other one will be VB. Now, all the capacitors that are coming between VA and VC, write them together. All of them that are coming, write them together. So first one, this is coming between what? A and C. I have added it, C. Second one coming between C and A. Again, it is coming between C and A. I've added it. This third one, this is coming also between C and A. I have added it. Fourth one, this is coming between C and B. Added. Now see, how can I write my whole circuit? This is basically what? Three capacitors connected in this manner with the fourth one in this. This was A point, this was B point. C, 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 C. Are you getting this? Why are we writing it in this manner? Clear to all of you? Hania, what about you?
Yes, ma'am.
Memona?
Yes, teacher.
And Sarah, what about you?
Yes, ma'am.
Okay, so now this is easy. These are three capacitors which are connected in parallel. So this becomes C3. 3C connected with C in series. That gives you 1 by C equivalent as 1 by 3C plus 1 by C. So C equivalent becomes what? It becomes 3C divided by 4. This is your answer. All right, so now note down these methods. And if you are still having doubt, then ask me again. I'll explain you again. So the next topic is Wheatstone bridge. If your capacitors are arranged in this manner, so Wheatstone bridge we'll be studying in detail in resistors only because it's a part of that. But it can come in your capacitors as well if your circuit is connected in this manner. Just look at the wiring, don't look at the symmetry. And a fifth capacitor has been connected in this manner. And the whole circuit has been connected to a cell. This is the EMF of it. So EMF, electromotive force, we'll be studying. Let's say this is C1, this is C2, this is C3, this is C4, this is C5. This is your point A, this is your point, let's say C, this is your point B, this is your point D. This is your point A, B, C, D. In this manner, if you are given. If in any case, what happens, C1 by C2 ratio, their ratio is equal to this, then you say it's a balancing condition. Now see, if bridge is balanced, then potential at this point VB, this is equal to potential across T. So VB becomes equal to VD. Don't worry about this Wheatstone bridge. This is not so important from your capacitors. I'm just discussing it because it can come. It can come. There's a slight chance of it coming. Otherwise, we'll study Wheatstone bridge in detail in your current electricity. Right now, this is not so important. But let's just discuss it. So potential difference will be VB minus VD. This will be 0 because both of same. So potential difference across this end will be different. 0. Potential difference across C5 will also be 0. Across C5 will also be 0. Some conditions, just remember this will, at least if not even in your exam, then at least it can help in your remembering for the next chapter. All right, now how to determine if the bridge is balanced or not? So to decide whether the bridge is balanced or unbalanced, we use a condition. We call it as a balancing condition. Balancing condition. If C1 divided by C2 is equal to C3 by C4, you call the Wheatstone bridge as balanced. This is called the balancing condition. If this happens, if you know 3 of them, fourth one can be identified. If you know it's a balanced Wheatstone bridge. Or if you have to check whether it's a balanced or unbalanced, you can take the ratios and check. And if it is a balance, then potential difference across these 2 points will be 0. It means no charge flows through it. You can remove it. If you remove this, no, what will happen? C1 and C2 will be in series. C3 and C4 will be in series, and both of them resultant will be in parallel. So just note it down. The point, types of capacitor that are important from your this chapter, that I'll discuss it. How to construct capacitors, how to identify them in series or parallel. Just make a note point and write this as well. Just text me done. Then if different plates are there, how to identify plates of same polarities. Now let's see if you're done with it. Let's see one important type of capacitors, how to identify in series or parallel. This is important from your CBSE perspective as well as from your entrances as well, because these kinds of questions have come in your CBSE questions as well as in your NEET and JEE, especially NEET. See, problems involving basically plates. So problems involving plates. Now, I'll be showing you how to identify it, but before that, just remember, if the plates have opposite polarities, then they are connected in series. Opposite polarities are connected. And in case of parallel, if the same polarities are connected. Now, how to use this? And also in this, C is equal to epsilon naught A by D will be utilized. So all those who have forgotten, this is the parallel plate formula of capacitance for parallel plates. Now let me show you how. So one question you will do yourself. You will try if it's possible, or I'll help you with it. See. This is a plate that is there. If you open your previous year's NEET and all books, this question is definitely filled with there. Let's say this is X, this is Y. All right. You have to identify whether these plates are connected. See, capacitor, as I've told you, it can be formed how? Two conductors of opposite polarities connected together can form your capacitor. Now, how these plates will form it? See, if I connect this plate to a, let's say I've connected this to a negative terminal and this to a positive terminal. So this plate is receiving positive, so this whole plate will become positively charged. Whatever plate is connected to one cell, make that plate completely of that charge, because obviously it will be of that charge only. So this plate becomes completely positively charged. This plate will become negatively charged. Now this is of your concern. Plates of same polarity or opposite polarity. So this is what? This is your first plate. This is your second plate. So yes, Hania, how are they connected? Same polarity or opposite polarity? 1 and 2.
Same.
How same? One is having positive charge. Second plate is having negative charge. So
Yeah, different.
opposite polarity. This plate, let's say the separation is D only. This plate is having opposite polarity. Similarly, this is 3, this is 4. 3 and 4, opposite polarity. 5 and 6, these plates, these are having opposite polarities. How are opposite polarities connected? Opposite polarity plates, these are connected in series. So this is also D, this one will also be D, this one also. D is what? D is basically the separation between all the plates. Whatever is the separation between all the plates, that we call it as D. So see, C1 will be equal to C2 will be equal to C3. This is equal to epsilon naught A by D, definitely. Now see, same polarities when they are connected, that forms your parallel plates, and whenever opposite polarities are connected, that forms your series plate. But see, now if we talk about these, if we talk about these plates, so this is your first plate, this is your second plate, and this is your third plate. So easy to identify it, whether they are connected in series or parallel. Now, whenever you have a such kind of setup, no, just forget this, leave this for a while. Easiest way to recall it, easiest way to remember this one. This is by looking at it. See, this is your first plate. Just separate all the plates. Let's say I've separated this plate. I've separated this 3 and 4. I've separated 5 and 6. 1, 2, 3, 4, 5, 6. All the plates I have separated. And see, if I connect all of them, they are connected with a single cell. So it means this is what kind of connection? All these 3 plates, if you arrange, this is your parallel connection. Means your C1 is this. This is your C2. This is your C3. See, this was 1 and 2. This was 3 and 4. This was 5 and 6. Connected to what? Connected to X and Y. So now this is easy. C equivalent will be what? 3 times epsilon naught A by D. Epsilon naught A by D plus epsilon naught A by D plus epsilon naught A by D. So this is how you identify it. Let's do one more question. Let's do one more question so that this concept will be easier for you. If I give you this plate, this is one plate and the other plate is this. This is your other plate. Now, this is X, this is Y. Let's say I've connected it and this plate becomes, for example, this becomes positively charged. This is positively charged. This is positively charged. Obviously, other plate will become negatively charged. This hole is negatively charged. Now, look at these plates. Plate 1 and 2. Opposite polarities are there. It means this capacitor does exist. Capacitor is what? Positively charged plate with a negatively charged plate. This exists. Now look at 3 and 4. Both of them are negative. Can we have a capacitor with both the plates as negative? Yes or no?
No.
No, we cannot have it. Means there is no such capacitor over here. That's what I was saying. Whenever capacitors are there with the same polarity, ignore it. If only opposite polarities are there, just see. This is 5, this is 6. Opposite polarity means only 2 capacitors are there. So, and see in this, whenever you see this setup, no, there are always been parallel connection. This will be, the C equivalent will simply be 2 times epsilon naught A by D. Reason, epsilon naught A by D of this plate, epsilon naught A by D of this plate. This plate does not exist because you cannot have a capacitor in this manner. All right, so this is how you solve such questions. So write it down. Wherever you're not able to understand, just ask me. This is not of so important. In this, you have to remember, if opposite polarities are there, plate exists. If same polarities are there, plate doesn't exist. Now the last topic of your capacitance as well as last topic of your whole chapter. If dielectric slab is somehow introduced, then how will you be able to solve it? Remember, this is one technique of solving it. If area gets divided, no, if you are able to see that area is getting divided, if area gets divided, then that connection is parallel. If you are able to see the distance is getting divided, distance between the plates is there, no, that small d that we take, if that distance is getting divided, it means it is connected in series. For example, let me give you a question. For example, this is a plate. Here's a plate. This side, this complete side, this is filled with a single this is filled with a single dielectric slab, and this another side, this is filled with another dielectric slab. Now this has become a by 2, this has become a by 2. Initially this whole was a. Now because of insertion of this k1 and k2, it has become a by 2, a by 2, and then this has been connected to a circuit. So this plate will become what? This plate will become positively charged. This plate becomes positively charged, and the other plate, this becomes negatively charged. Now, as I've told you, if you have area getting divided, it means it is connected in parallel. So it's like you have two capacitors that are connected in parallel. In this manner only, C1 and C2, in this manner. So if they are connected in parallel, C equivalent is given by what? C1, C2 divided by C1, C2 divided by C1 plus C2, means I have written this only. 1 by C equivalent is 1 by C1 plus 1 by C2. If you take the LCM, it looks like this. So 1 by C equivalent will be what? You have this separation is what? This separation is D. So D is remaining the same. See, D remains the same here. What is getting divided? Area is getting divided. It means if area is getting divided, you have the combination as parallel. So just simply put it, C1 will be what? C1 will be epsilon naught A by K1 to A by 2. C2 will be epsilon naught A by, this will be, D will be there. K1 will also come in the numerator. This will be K times epsilon naught A by D is there. This will be K1 A epsilon naught times D. This will be K2 epsilon naught A times D. This is the capacitance that you have. Just reciprocal it and add it. This will be what? Both of these are getting multiplied. So just take the reciprocal, it will be 2 times D by K1 A times epsilon naught plus 2 times D by K2 epsilon naught A. So C equivalent will directly, then you can write it as, this will be epsilon naught A by 2D. If you take it as common, so it will be K1 plus K2, reciprocal of it in this manner. Now this is one case. If I give you another case, if I give you another question where I have these plates. Now I have inserted the dielectric slab over here, and the other dielectric slab has been inserted here. Means in this manner I have inserted the dielectric slabs. Now see what is happening. This is K1, this is K2. Whatever your area, it was remaining the same, but distance, this separation is getting divided. If the distance is getting divided, from here you can identify that this is connected in series. So connected to a battery, One plate becomes positively charged. This plate becomes positively charged. This will become negatively charged. Now, if you remember induction, when we had discussed in the first class induction, what happens? Charges get induced. So if this is negatively charged, this side will automatically become positively charged. Similarly, this side, this will become negatively charged because of induction. But majorly what you have to remember is that they are now connected in what? Series or parallel? Yes, class, are they connected in series or parallel? Distance is getting
Parallel.
divided.
Series.
Series. See, its distance is getting divided. Remember this. Distance getting divided, series. Area getting divided, parallel. If you get such a scenario where area is getting divided, quickly write it as parallel. If you see distance is getting divided in this manner, so answer will be what? Both of them are connected in series. So first one and second one, 1 and 2, these are connected in series. So, okay, it will be 1 by equivalent for this one. No, this was parallel. This I have written it for register. See, this formula 1 by equivalent is for, this is for series, no? And here it was coming out to be, you just have to add it in this one. See, this one is wrong. This I have written it for register. Both of them are connected how? Parallel. In case of parallel for capacitors, we just add it. It will simply be C1 plus C2. Just add them. K1 epsilon naught A by 2D plus K2 epsilon naught A by 2D. This will be your answer. Reciprocal, we will take it in case of series. This will be C1, C2 divided by C1 plus C2. This is series in case of capacitance. This is how you write for capacitance if you have. So here you have to write sequent. See, C1 will be what? K1 epsilon naught. Area will be the same. Distance will be what? D by 2. C2 will be what? Similarly, 2K2 epsilon naught A by D. This will be the change. Now, if you add them, if you see they are connected in what? Series. Now, in series, we add them in this manner. No, 1 by C equivalent is 1 by C1 plus 1 by C2. Both of them, just to make a correction if anybody has noted it down. If they are connected in parallel, we can simply add it. We don't need to take the reciprocal. These are not resistors. We have to just add them. In case of series, in this manner, we have to take the reciprocal. So 1 by C equivalent will be what? It will be D divided by 2K1 epsilon naught A plus D divided by 2K2 epsilon naught A. In this manner, you have it. So let's take D by 2 epsilon naught A common. What is left? 1 by K1 plus 1 by K2. This is left. Let's take the LCM. 1 by C equivalent will be what? D by 2 epsilon naught A. K1, K2 will be the LCM. So it will be K2 plus K1. K2 multiplied here, K1 over here. So C equivalent will be what? Reciprocal of it. 2 epsilon naught A K1 K2 divided by D K1 plus K2. This is how you write it. So remember in this question, just make a correction if anybody has noted it down. I had written it for register. For capacitor, we just have to simply add it. If they are connected in parallel, we simply have to add it. If they are connected in series, in this manner, if they are connected in series, then we have to take the reciprocal and add. So how to identify whether they are connected in series or parallel? Area is getting divided, parallel. Distance is getting divided, series. Clear? Is this clear to all of you?
Yes, ma'am.
All right, start noting it down, and if you have any doubts, ask me in between. So this completes your chapter, potential and capacitance. One question I'm giving you as a homework. This you will try on your own. So in the next class, we'll discuss the answer of it, and then we'll begin the next chapter, that is current electricity. So 3 dielectric slabs are given to you. One is this one. Other dielectric slab is this, in this manner. And a third dielectric slab is there, filling it in this manner. These are your dielectric slabs given. So take it as K1, take this as K2, take this as K3. See, in this manner, what is happening? A by 2, but this is becoming D by 2 and D by 2. So you should identify what are these. Then the resultant is connected to this in what manner? This is D only. All right. So just note it down, try it. We'll discuss it in the next class. And this completes of your chapter, potential and capacitance, electric potential and capacitance. In the next class, inshallah, we'll start with a current electricity. Just note down and text me done. So I know you have written it down. Okay, Hania, Salman, Khalid, done. What about others? Sara, done. Done? All of you have done it. All right. So I'm stopping here. Revise this whole chapter, first and second chapter. Start revising.